This video is about phase difference. In the previous video, we learned about simple harmonic motion graphs. Observing the motion of a horizontal spring, we created a displacement time, a velocity time, and an acceleration time graph for the motion. If it's not fully clear how we got these graphs, feel free to watch the previous video. Comparing the three graphs, we see that they all have the same sinusoidal shape. In other words, they are sine function graphs, and we can also observe that these sine graphs start at different points and they are horizontally shifted when compared to each other. This horizontal shift is what we call phase difference. Let's start by examining the phase difference between the displacement time and the velocity time graphs. To do this, I will sketch the velocity time graph together with the displacement time graph like this. To find the horizontal shift or phase difference between the graphs, we just need to pick two corresponding points on the graphs, so for example two neighboring maximum or two neighboring minimum points, and find the horizontal distance between them. Here I will use the minimum point. The time period of each graph is t. The time period here is represented by 8 squares. The distance between the minimum points on the graphs is 2 squares, which is a quarter of the time period, so t over 4. Therefore, the phase difference between the displacement time and velocity time graphs is t over 4. In physics, we often use radians or degrees to express phase difference. Since the time period t corresponds to a full cycle or oscillation, it is equivalent to 2 pi radians or 360 degrees. So now we can conclude that the phase difference between the displacement time and the velocity time graphs is t over 4, which is equivalent to pi over 2 or 90 degrees. Comparing the displacement time and the acceleration time graphs, we can see that the phase difference between them is t over 2 or pi or 180 degrees. Finally, the phase difference between the velocity time and the acceleration time graphs is t over 4 or pi over 2 or 90 degrees. A final note about terminology is that when the phase difference is 0, the two graphs are said to be in phase. This completes our discussion about phase difference.